Okay, YouTube, today we're going to go through a problem that had been bugging me for a really long time, that I was having a problem solving, and finally figured out what the issue was, which was not a place you normally think to look when you have this type of problem. Specifically related to a fishtails and the switch matrix. And here's the switch matrix from fishtails. You know, I don't know, maybe I need to shut this light because it's causing, whoa, don't knock the camera over. Let's see if you can see it any better now. Yeah, so here's the switch matrix from fishtails, and the problem was that in fishtails you've got switches 16, 17, and 18. Okay, these three switches, which I'm going to highlight with the balls in the ball trowel. Okay, and when someone would hit a switch, then when the owner would hit a switch in row 2, let's say they hit switch 42, the right boat entry, okay, like this, what would happen is at the same time it would trigger switches 46, 47, and 48, and those would be the L switch, the ball popper, and the drop target. Okay, so this is indicative of the classic square problem in a switch matrix where you have a bad diode, where basically if you have a switch triggered in a column and a switch triggered in a row, what would happen is other switches where that row and column intersect would trigger at the same time. And what you do is you then complete the rectangle here. So if I go over here to complete the rectangle between the column and the row, it tells me that switch 12 is involved in the problem here. Okay? So now I have to look at the issue of what's switch 12. And if you look at the switch matrix chart for switch 12, it says switch 12 is not used. Now this person was adamant that all the switches in the playfield were good, all the diodes in the playfield were good, everything was fine. And the CPU board was fine, but he was still getting this magic rectangle that was being caused by the a problem in row 2. So after a lot of work and a lot of swapping and investigating, it was discovered that the problem was actually on the power driver board. And you say, what does a power driver board have to do with the switch matrix? And I'm going to show you now what the problem is. So I have this machine set up in switch test. This is actually a World Cup soccer, but you'll see the problem. And if I click, and I have a little Siegecraft tester here, and I can test each switch, and there's 1-1, there's 1-2, which is the goalie switch. You know, I'm hitting this flipper switch at the same time here, but if the goalie switch, see, 1-3, 1-4, see, it's all fine. If I do 2-1, it's always hard to do. Say 2-1, 2-2, 2-3, 2-4 is always closed on the WPC, which is what this square is here. So see, all that works fine, but if I go now and I close switch 2-2 on here, you'll see I get the switch 2-2, and now if I press the goalie switch, which is I'm sorry, if I press the that's, well, 2-2 is coin door closed. let's see, what do I want to press here? If I press 2-2, and then no, I want to press 1-3 is what I want to press. 1, 2, 3. If I press 1-3, which is the start button, and I can press the start button on the machine too, because I have the back box switches hooked up here. If I press the start button, and then if I press 2-2, you'll see that switch 2-3 lights up as well. If I release it and then hit the start button, see, I'm getting 2 switches for the price of 1 there. If I hold the start button down and then I hit 2-2, see, I get 2-3. So here I'm getting a square indicating that switch 1-2 is bad. Now I know switch 1-2 is not bad in this machine, it's fine. So after investigating and swapping things out, as we said, we determined that the problem here was on the driver board. And if you look at the schematics on the driver board for the power for WPC schematics, and these are really kind of low res, but you'll see that there are 2 rows and 1 column that feed to the driver board from the ribbon cable from the CPU board. If you can see that, I've highlighted in yellow. And if I go to the other page of these schematics and show you where these go, you're going to see that they go to 2 opto isolators, one at U7 and one at U8. And it turns out that the opto isolator at U7 is in row 2 of the switch matrix. Now, the opto isolators that are used on the driver board are normally used to sense when the flippers are pressed. And the opto isolator has, here's the data sheet for the opto isolator. It's a 4N25, or sometimes known as an optocoupler. Okay, and you'll see that the optocoupler has a gallium arsenide infrared LED on pins 1 and 2, and an MPN phototransistor on pins 4, 5, and 6. So let's pull this opto isolator and see what it looks like. Okay, so where are the opto isolators on the driver board? They are right here. These 2 little guys right here next to the flipper relay. Okay, and you have U7 and you have U8. Alright, and U7 is the one that's in row 2, and U8 is actually in row 1, and they're both hooked up to column 1. Now, these 2 are normally soldered to the driver board. They're not socketed like this, so they're not easy to get out. And if you don't have experience soldering fine traces and small pads, I would recommend you don't try taking these out yourself. Give it to someone who does and who has the equipment and who can get this done. So what I've done is I've swapped both of these out, and I'll explain why in a minute. But U7 is the one that we're most interested in. So what I've done is I've pulled it out, and I have our Atlas DCA Pro here. And what I'm going to do is I have, this is the faulty, this was the one that I pulled from U7. So now looking at the data sheet, see pins 1 and 2 are the LED, the internal infrared LED. So if I hook up my DCA Pro to pins 1 and 2, let's see if it tells me if this is a diode junction, because it should. So if I hit the test button, and you see it says it's a diode junction, okay? Because the 4N25 is really two parts in one. There's just the as indicated by the data sheet. So this is a completely valid test using the DCA Pro to test this. Now what we want to do is we want to hook all three leads up to pins 4, 5, and 6 on this 4N25 and see what we get. So I've hooked, a bit of challenge getting all three on at the same time. So I've hooked all three pins up, as you can see here. Now I'm going to hit the test button. And you see it says no component detected. That means that internally this 4N25 is dead. And just to show you, I have a good 4N25 here with me, and I'm going to hook that up now to leads 4, 5, and 6, pins 4, 5, and 6 I should say. Okay, and now if I hit the test button, see it says it's an NPN transistor, which is what it's supposed to be, because this is an NPN photo transistor. So this guy here was bad, and what I've done is I've swapped in a new one on the driver board, and let's take a look at how this functions. Shut this, turn the machine on, shut the light because it'll be easier to see, and don't worry about that message because it's not, the switch matrix isn't hooked up. I go to tests and I go to switch edges, and remember previously I hit switch 1, 3 and 2, 2, right, and I was getting 2, 3 when I did that. So here's 2, 2, and now I'm going to hit 1, 3, and I'm not getting anything. As you see, I'm only getting the one switch now. And if I hit 1, actually I was hitting 1, 3, and then if I hit the start button, oh, that is the start button, and then I hit, no, 2, 2, that's what I want to hit. Do the same test I did last time. So I hit 2, 2, and I hit the start button. See, I'm only getting one button now. I'm not getting 2, 3, which I would get if 1, 2 was bad, which it was bad with this photo opto isolator, opto coupler. So there you have it. There's a problem if you have a switch matrix problem that's daunting you and you don't know where the problem is and you can't figure it out after everything else. It might not be on the CPU board, it might not be on in the switch matrix itself. It could be on the driver board, and it could be one of those optocouplers. Alright, thanks.